Hi, Chem Squad. In today's lesson, we're going to go over the history of the atom by looking at all the different atomic models that have occurred throughout history, which is pretty much about 100 years ago. So let's start with the first model called the Dalton model. So the first model of the atom is fairly simplistic. Basically, all atoms are tiny, indestructible spheres and back then there were no such thing as electrons, there's no protons, and there were no neutrons. So basically there were no subatomic particles. Okay. So the easiest way to represent this particular atom is just to draw in a tiny dot with nothing else in it. Okay. So this is a very accurate diagram of a Dalton model of an atom. This model was the model of an atom for most chemists for about 100 years until the early 1900s, where we got an upgrade on it. And the upgrade came from a man named Thomson, and thus it was called the Thomson model. In the Thomson model, we finally started peering inside the actual atom and found that there were subatomic particles. So in this model, one of the first things that were discovered were electrons. So the electrons are present, but not the protons, okay, not in the same way. Okay. Positive charges are present in a cloud, or something that was described as a cloud, okay? But they were not called protons, so there's still no protons, okay? And if there's no protons, there really wasn't a nucleus either. So the nucleus has not been discovered yet either. But what was kind of odd about this particular model, okay, is that when you looked at it, it's still spherical, okay, and you still have electrons in this atom, but the electrons were embedded in a jelly-like substance. Okay, so if I use red here, and I'm just shading in all the empty spaces here, all the empty regions, okay, this was a jelly-like substance, or what they thought to be a jelly-like substance, with electrons embedded. Within. So because the electrons are embedded in this jelly-like substance, this particular Thomson model was now also known as the plum pudding model. Okay, and since Thomson was British, plum pudding is a very common type of bread that basically was embedded inside cake. Okay, now the American version of this is basically raisin bread. So in America, the plum pudding model, or Thomson's model, was also known as the raisin bread model. But we today know that this particular model of the atom is incorrect. And it didn't take too long for this model to change. Okay, it was within a matter of a decade, or even less than 5 years. But when change did come, it was Rutherford who made the change. Okay, so the Rutherford model looks a little bit more like what we kind of think of as models of the atom. First and foremost, there is a nucleus now. Okay, and within the nucleus, we had protons. Okay, so just going to label this as the nucleus. So the nucleus is present in the Rutherford model. And all of that positive cloud is actually now thought of as positive particles called protons. Okay. But the problem that they had was with the electrons. So under this model here, the electrons moved around the nucleus. Okay, so if we drew in a few electrons like this, okay, I'm sure you guys have seen pictures or diagrams in old textbooks that show atoms looking like this. Okay, but it's the way the electrons were moving around that was incorrect. Okay. The electrons here moved around the nucleus, which is fine. Okay, it should move around the nucleus, but it was in random directions. Okay. The movement of electrons is not random. But in this simple diagram, we went from a plum pudding model where electrons didn't really move, okay, they were trapped, to a model where electrons are moving and they're just thinking, okay, well, they must move around randomly. Okay, but really, the big thing was the nucleus being present, okay, with protons inside. So from Rutherford, the next model that we come to is the Bohr model. Now this is the one that you guys know of quite well, because we still use it, even though it's inaccurate. So here's how you classically thought of the Bohr model. Okay, you had a nucleus in the center, and then you have these rings or shells that contained electrons, like this, right? This is the classical Bohr model. I have a much simpler method of drawing out the Bohr model that I'll show you, but we'll look at how the electrons are affected here. Okay. So the electrons in the Bohr model moved in perfect circles. Around the nucleus. Okay. Meaning the movement is no longer random. Okay. And that's the one thing that they got, that it's not random, but electrons doesn't move around in perfect circles either. Okay, and that will be explained in the quantum model, which is the most current accepted model of the atom. The other good thing about the Bohr model is that it also represents neutrons too. So neutrons, okay, we'll use that as our symbol for neutrons. Neutrons were contained inside the nucleus. Along with the protons. Okay. So, like I said, we have a different way of writing out these Bohr models. So I'll give you a different way that we can do it. So if I take a atom like this, within the nucleus I have my protons and my neutrons, right? So this is my nucleus. But instead of drawing the shells around the nucleus, I use vertical lines to represent the shells, like this. So in that first shell, you can hold 2 electrons. Okay, so this first shell, it's also thought of as an energy level. So we can say this is the first energy level. It can hold 2 electrons. The second energy level can hold 8 electrons. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. And if we keep moving to the third, okay, we can hold another 8 electrons. Okay, and then as we keep going up in the fourth and the fifth, okay, I'm not going to draw all the electrons in, but at these energy levels, you can hold 18 electrons. Okay, so each one of these energy levels can be given a name. And I don't know if your teacher last year identified what the names were, but the first energy level or first shell is called the K shell, okay, or K energy level. And then the next one is L, M, N, O, and then it continues on with the letters of the alphabet. Okay, so if I wanted to write out a lithium atom, all I really need is the total number of electrons. Okay, and in this case, the total number of electrons is 3 electrons. So if I were to draw this out, I would have the nucleus. Okay. Put in my 2 electrons here in the K shell, and put in 1 more in the L shell. Okay, so it has 2 electrons, 1 electron, and that would be my lithium atom. So from Dalton to Bohr, we have a series of gradual changes. Okay, you can see how the atom gets more complex as we move from Dalton to Bohr. In the next atom, which is the quantum model, oops. Okay, so the quantum model, we're going to look at a completely different type of model. It's much more complex, and because of its complexity, I will need to put it into a different video, okay, just so I can focus just on the quantum model, because it'll pretty much take me just as much time to explain the quantum model as I did with the Dalton all the way up to Bohr. So once you're done with this video, just click on the next video and I'll continue with the lesson on atomic models.